So this is the state space model that models this DC motor, and we want to find its transfer function equivalent, which is a model that relates the motor speed to the applied input voltage. So in doing so, it is very important to know the general equation that relate the state space model to the transfer function model. And we do that by taking the Laplace transform of 1, which will give us this equation, and collecting like terms, we have this equation. So as you can see, we multiply the identity matrix I to S because we are dealing with matrices. So now multiplying both sides by Si minus A inverse, we'll end up with this equation, which is equation 3. Now we take the Laplace transform of 2 and we'll have equation 4. So all we need to do is to substitute 3 into 4 and we'll end up with this relationship, and factorizing u of s, we are going to get this equation. And we know that transfer function is just the ratio of the output to the input in S domain. So therefore, this is the general relationship that relates the transfer function model to the state space model. So now let us apply it to our conversion. So from our given state space model, we have our A, B, C, D matrices as this. Now applying this to the formula in 5, we are going to get this relationship. As you can see, from 6, the main important thing is to find this inverse. So finding this inverse will end up with this matrix, and substituting it back into 6 will end up with this relationship. So now we just have to apply matrix multiplication. So as you can see, multiplying this by 0 and adding this times 1 will end up with this row, and doing the same thing, we are multiplying this by 0 and adding this times 1 will end up with the second row. So what we have to do is to do the second multiplication. So we just have 1 times the first row plus 0 times the second row. So the transfer function equivalent of our given state space model will just be 1 over s squared plus 100.1s plus 11. So let us go to MATLAB and see how it is implemented. So here we are in MATLAB. I have my A, B, C, D matrices. So the output of my function, the function I'm going to do, will just give me my numerator coefficient of my transfer function and the denominator coefficient. And the function is state space to transfer function, and it carries the argument of my model matrices, that is A, B, C, and D. So applying enter, I have my numerator coefficient and denominator coefficient. If you want to see the transfer function, we just use G and we use the function TF, and I just put my numerator and denominator as the two arguments. So this is my transfer function model. If you want to learn how to convert transfer function model into state space model, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.